The price of lithium has been consistently increasing at an alarming rate. This has encouraged many of the startup companies and OEMs to begin developing alternative battery chemistries such as sodium-ion batteries. There is a German company that is producing, not researching or testing, but producing a lithium-free, cobalt-free, graphite-free, and copper-free sodium alumina solid-state battery that has a lifespan of beyond 15 years with an energy density comparable to lithium iron phosphate cells, and it operates at extreme temperatures. Hello friends, and welcome to The Electric Chemist. Thank you for tuning into the channel. On this channel, we discuss all things battery development, including existing lithium-ion batteries, new and emerging battery systems, battery supply chain, battery production, and battery application. If this is something that interests you, please subscribe to this channel, smash the like button, and keep watching. Now, there's been a huge focus on battery production for electric vehicles, but one of the renewable energy sectors that has been steadily growing for a long time is the grid energy storage market. Therefore, developing batteries for this application is very important in our quest to diversify energy generation. When it comes to stationary applications such as grid energy storage, I believe that sodium batteries are the ideal candidate because weight limitations and energy density are not key requirements. Sodium-based batteries are also safer and have the potential of being cheaper than lithium-based batteries in the long run. Now, Alltech Chemicals Limited, a German specialty battery technology company with a technology in alumina used in ceramics, has executed a joint venture agreement with the leading German battery institute, Fraunhofer IKTS, to commercialize the sodium alumina solid-state battery. The sodium alumina solid-state battery uses high-purity alumina for the critical ceramic solid-state electrolyte. Now, I have to give credit to Alltech Chemicals because we will be talking about their product on this channel, and they have a YouTube channel, so you can check it out. But in this video, I would just like to give my perspective as a battery engineer with over 5 years in the industry. Well, what makes this battery stand out? Firstly, unlike lithium-ion batteries, these batteries do not contain any lithium, but use sodium ions from common table salt. The cathode electrode does not contain any cobalt, graphite is not used as the anode electrode, and the current collector is not made of copper, so there are a lot of differences between these and lithium-ion batteries. Therefore, this battery is not exposed to the rising prices, potential supply constraints, and ethical issues surrounding these critical materials. Secondly, these batteries are fire and explosion proof because they do not contain any flammable liquid electrolyte or plastic separators, and their cathode electrode does not contain any oxides nor generate oxygen, so they are not prone to thermal runaway, which is the cause of battery fires in lithium-ion batteries. Another advantage of this type of battery is that they have a large operating temperature range between minus 20 degrees C to plus 60 degrees C with high performance and durability. Also, unlike other solid-state batteries that easily feel hot to touch, these batteries are fully insulated, so the external part of the battery module is at a human touch, that is, they're not very hot to touch, and the internal structure, even though it's at high temperature, the outside is still cool and okay, so they do not require cooling like in the case of lithium-ion batteries, which actually make their battery pack to be heavier. Furthermore, the battery lifespan of these solid-state batteries exceeds that of commercial lithium-ion batteries because they have been reported to have lifetimes of over 2,000 cycles, and more than 15 years have been demonstrated with full-size batteries. Now, as a battery engineer with over 10 years of experience, these results, this data of this battery are really impressive. If you're enjoying this video so far, please hit the like button and subscribe to show your support. Now, how does this battery work? When they are charged, electrons flow from the positive terminal to the negative terminal. Sodium ions from the salt migrates through the solid ceramic electrode towards the negative canister terminal. The remaining chloride ions attach themselves to the nickel to form nickel chloride in the cathode medium. Then the sodium forms a molten layer on the outside of the ceramic tube, contacting the steel canister, and the battery becomes fully charged. During discharging, electrons flow back. Molten sodium is oxidized into sodium ions and transferred back through the solid-state ceramic tube forming sodium chloride, while nickel chloride is reduced back to metallic nickel. So you can see how the mechanism works. Now, the biggest downside to sodium-ion batteries is that they have a lower energy density than lithium-ion batteries. So how does this battery actually compare to lithium-ion batteries? These zero-energy batteries, these solid-state batteries, have excellent specific energy of 110 to 130 watt-hours per kilogram compared to LFP lithium-ion batteries, which have up to 160 watt-hours. So they're just about 30 watt-hours per kilogram shy of LFPs. They charge over 4 to 6 hours and discharge over similar times, which is ideal for the grid storage market. Now, all this information sounds exciting so far. The parameters and the properties of this cell are really good, but this is not the first time sodium-based batteries have been talked about, because giants like catl, foryou in the UK, and Haina in China have all talked about making sodium-ion batteries, but they are not yet commercialized yet. So what is the status and commercialization plans for this company? Well, Alltech has elected to develop a 100 megawatt-hour zero-energy battery plant in Saxony, Germany. And once this plant is built and operating, the long-term vision for the company is to consider additional trains or gigawatt-hour battery facility in Germany as well. The battery plant will produce 1,666 battery packs per annum, rated at 60 kilowatt hours each. And the company has actually made some significant headway in achieving this. These modules are expected to sell for between 700 to 900 euros per kilowatt hours, so they are really affordable. Fraunhofer has estimated that the cost of goods sold for the batteries should be in the region of 40 to 50% cheaper than lithium-ion batteries. This is significant because catl said that theirs is going to be about 30% cheaper than lithium-ion phosphates, which are currently the cheapest batteries. So these batteries are poised to be cheaper than catl's batteries. I believe these batteries, in my opinion, are ideally suited for the grid storage market or long duration energy storage, where very high power in a short period of time, like high power EV, is not required. So these batteries can be configured to meet up to 600 volts, which is required for grid storage. The company has made significant steps towards meeting demands of modern electricity grids. So I believe that this technology will help strengthen electrical grids all around the world, supporting renewable energy storage solutions, while mitigating some of the environmental challenges involved in the mining and manufacturing and refining of lithium and lithium-ion batteries. But, let me know your thoughts in the comment section. Tell me, what do you think? Do you think this company is potentially going to be a leader in sodium-based batteries, especially for grid energy storage, or not? Give me your opinions in the comment sections, and if you've enjoyed this video, please show your support by smashing the like button, because it will really help the channel, and also subscribe to this channel. Thank you very much. I love you, I appreciate you, and I'll see you in the next video.